Hello, I just wanted to make a quick video about a problem that a lot of people missed on the most recent quiz. There was a problem with the limit as x approaches 0 of sine 7x over 2x. First, a couple things that you're not allowed to do. A few of you just looked at the coefficients here and said this was 7 and this is 2, so the limit is equal to 7 over 2. Now, although that is the right answer, this limit is equal to 7 over 2, that is not the way to do it. Comparing these coefficients is not the calculus way that we want you to prove and show analytically how we get this limit. One more thing that you're not allowed to do to solve it, to actually show the calculus work, is this is actually erroneous. You're not allowed to do this. There's nothing in trig that says that sine of 7x is equal to 7 sine of x. So if you use that in any way, that is definitely not a true statement, so you're not allowed to do that either. Let me get to the way we're looking for, the way we want to do it. So what we want to use is this theorem that says the limit as x approaches 0 of sine ax over ax is equal to 1. And the key to being able to use this is that this coefficient and this coefficient have to be the same before we can say that that part of the limit goes to 1. So our challenge is to manipulate our function sine 7x over 2x and make those two coefficients be the same, the 7 and the 2. There's nothing we can really do about the 7. Like I said, you're not allowed to pull that 7 out or anything, so that 7 is sort of stuck. But we can move the 2 because there's no trig function here. This is just 2 times x, so we can do all kinds of things with that 2. So what I'm going to do is say that this limit is equal to the limit as x approaches 0 of sine 7x over x, and move the 2 by just saying I'm going to multiply that by 1/2. Right? These two things are definitely equal to each other. If you multiply it out, you get sine 7x over 2x for sure. So this definitely works. Now the other thing I have to do is, again, I need a 7 here. So I'm actually going to give that denominator 7 by multiplying by 7 in the denominator. Now, of course, to keep this equal, I have to also multiply by 7 in the numerator. This next step, what I'm going to do is I'm going to rearrange where all these constant multipliers are. So I'm going to leave the 2 where it is, but this 7 right here, I'm going to put with the x. So it's sine 7x over 7x. This is definitely true. If you're multiplying, you can put these multipliers in any order you want. And then I'm going to put the 7 and the 1/2 together by saying that's 7/2. All of that is just some manipulation. All I'm doing is changing the order and using some properties of algebra to change the order of those numbers around. Now that this looks like this, I can use that theorem and say that this is going to approach 1. So what I have here is 1 times 7/2, which is equal to 7/2. Okay, so that's the correct way to show that calculus work that we're looking for in order to do that problem correctly. If you still don't understand it, there's another example in the static version of the Chapter 2 practice, the solutions to the Chapter 2 practice. It's problem number 3. Okay, so you can look up in practice tests in our Blackboard site and find that solution to problem number 3 from the static version of the Chapter 2 practice test. All right, I'll see you on Wednesday.